I picked up some time ago the Insta360 Ace Pro for my return to FPV, but it turned out to be a little bit too heavy. For vlogging though, this is a generally impressive camera, but it has some terrible flaw that nobody solved yet, so I did it. Hello everyone, this is Shah, and today we are going to make something the world was missing. While the GoPro 14 is yet to show up, the Insta360 Ace Pro remains one of the most powerful action camera on the market right now. In many ways it beats my bigger cameras. Smaller, more portable, almost 50 megapixel with Leica lens, 2 true 4K field of view, a flexible built-in mic, flip-up screen, 4K 120 frames per second and 8K. The low-light performance is generally impressive too, thanks to a sensor far larger than any ordinary action cam. But that bigger sensor brought a problem nobody properly solved yet. Larger sensor means shallower depth of field, and that means the minimum focus distance is significantly further than a traditional action cam. At arm length, it struggles to focus on my face. Get closer for more dramatic shot and you're just blurry. It's also a capable photo camera, but the grip is terrible. Or better, there is just no grip. You can buy the Explorer kit, but at that price, it has an embarrassing flaw. Mounting anything on the cold shoe and the flip-up screen becomes completely useless. So I decided to solve all of it at once. And maybe add few things nobody thought of. Follow me along the design and the making journey. I explain my workflow and the reasoning behind every choice. One of the most important lessons from 12 years of engineering. The precision of your constraints defines the quality of your output. Spending a couple of hours to properly measure and build a digital twin of the AcePRO enables much faster and more precise design work around it. It's never time wasted. Once the reference is properly built, the caliper goes back in the drawer and stays there till the end of the project. Designing around a precise visual reference lets your brain fully focus on creative work, without constantly stopping, measure, and verify. Once the cage around the camera was designed, a careful analysis led me to one key decision: open up the battery side completely. Because that's exactly where the ergonomic grip attaches, and the grip itself becomes the locking mechanism for removing the camera or swapping the battery. But how well the locking clip concept would actually work? That was my biggest doubt. So before committing more time to designing further details, I ran a preliminary prototype print. Another good practice learned over 12 years. It saves an enormous amount of time. First impression straight off the printer. The cage walls feel soft, not durable enough. The top clipping bar looks fragile too. Definitely needs more material. The lower clipping wall looks a bit odd geometrically, but feels surprisingly strong. The grip, however, feels solid, and the hooks are looking good. The fitting of the AcePRO into the cage is flawless. The digital twin delivered exactly what it promised. Now the moment I was dreading most. Hook on the top, rotate the bottom clip, and that click, crisp, satisfying, zero play, sturdier than I expected by a long margin. To release it, you simply unlock the bottom clip, and the two parts come apart effortlessly. Battery swap takes seconds. Flip-up screen works exactly as designed, no interference. Quick ergonomics check. I like the grip. And this imaginary shutter button? I could get used to that. Let me show you how I solved the cold shoe problem. On every commercial cage out there, including the official Explorer kit, the moment you mount a mic or a light, you can't film yourself anymore. I'm genuinely surprised they all made the same choice. I moved it to the tip of the grip. Screen stays free. Mount whatever you want on top, it doesn't matter. With a good amount of satisfaction from iteration 1 and a clear list of things to fix, we go back to the CAD. First, thicken the cage wall and the top clipping bar. Then I realized something. Once the shutter button is added, it would block the cold shoe entrance. So I rotate the cold shoe orientation to solve it before it becomes a problem. Next comes the shutter button, a long lever, hopefully rigid enough, we'll find out. And here is the second highlight of this design, the lens filter bay, designed flush to the original lens surface, no field of view interferences, and that's simple to install. And then the clip-in filter holder itself, a single piece design. Drop the filter in, snap it in place, done. The cage already feels significantly stronger. The added wall thickness and the filter bay bridging both sides made a real difference. The camera sits flush and clean. The closing mechanism still works perfectly with the shutter bar added, and that click even more satisfying than before. Let's hear it again. One more time. Shutter button check, and nothing. The lever bends too much, not enough rigidity to actually press the button down. This needs work. Ergonomics feels good though. Quick release works. Cold shoe is usable, and the shutter trigger clears it cleanly. Good? The mic adapter won't go in. Too tight. Needs more clearance there. First filter fitting tryout. Easy. Looks incredibly nerdy with that silver ring. Let's power on the camera. No vignetting. But then I call my own mistake. The screen couldn't flip all the way up anymore. More work. The filter removal though, watch how fast that is. Now let me explain why I went this direction entirely. There are solutions on the market already, but they are all friction held, which I think is simply not safe enough for an action camera. One knock and your filter is gone, and they only work with a filter made specifically for this camera. But those of you who are passionate about photography already own a full collection. ND, polarizer, macro, whatever you need. My design lets you use all of them. Any size, just print a 5 minutes holder for each one. Drop in, done. But let's go back and fix what's left. And I have a feeling we're approaching the end of this project. A little more clearance for the screen to flip fully up, more wiggle room for the mic adapter, and most importantly, the shutter lever needs serious reinforcement. Better cross-section geometry for improved rigidity, and just for extra safety, a bit more travel distance under the bottom if needed. One more thing, very important, my logo goes on, then we print. And still not working, not consistently anyway. Back to the CAD, print again, still not reliable. At this point I could keep guessing, or I could use the right tool. Time for FEM analysis. Finite element analysis lets me simulate exactly where the lever is bending, how much and under what load, without printing a single prototype. This is how you stop iterating blindly and start engineering deliberately. With the confidence that this was finally the right one, I gave it all the love it needed. Every support carefully removed, every surface finished properly. Then for the logo, a toothpick, UV nail polish, a magnet to arrange the metal pigment, a few seconds of curing. The logo is alive. Ladies and gentlemen, the world's most complete and versatile grip cage for the AcePRO and AcePRO 2. Here is everything you get. And to match the professionalism of the FEM analysis, we are going to do some equally professional optical test. I'm gonna put this small optical test chart on the professional test stand so you can evaluate how sharp is my face at arm distance. Now take a second, zoom in. Okay, and now we put on the +2 close-up filter and zoom in again, and you see, boom, this is how sharp your face should look when vlogging. And good news, I decided to share the STL file of this grip with you for free. Link in the description. And if you want to support the channel, there is also a Ko-fi link there too. Let me know if you like the project and if you want to see more of this, or feel free to suggest for other video ideas. And don't forget to subscribe. See you next time.